Lesson 7-2, Parabolas. You probably know of a parabola as the shape of the graph of a quadratic equation. But we can define it a different way. We can say it's a set of all points in a plane that are equidistant from a fixed line called the directrix, that's the dotted line in my graph, and a fixed point called the focus. It's a point I've labeled F. So the distance between the directrix and the focus is the same to any point on this parabola, which means that our vertex, which I've labeled V in the graph, is halfway in between the focus and the directrix, and it is our minimum or maximum point and midpoint between the focus and the directrix. The axis of symmetry is the line that's perpendicular to the directrix, and it goes through the focus and the vertex. So you can see it's labeled axis in the graph. Notice the parabola bends around the focus and away from the directrix. This can be vertical, horizontal, left opening up, down, left, or right. If it's a vertical parabola, it'll open up or down, and the axis of symmetry is vertical. We need to define a few things. P here is the directed distance from the vertex to the focus. So they'll be going up if it's positive, it'll be going down if it's negative. The vertex is at HK. The focus is at HP plus K, so we're at HK and then go up P, so that's why we add the P to the K. And the directrix is y equals K minus P. So the y value was K, but then we went down the distance P because the vertex is directly between the focus and the directrix. And you can see in yellow there the standard equation of a vertical parabola. If it's horizontal, it's the same idea, only it opens left or right, with the axis of symmetry being horizontal. P is still the distance from the vertex to the focus. It'll be positive if it opens towards the right, and negative if it opens towards the left. And you can see now for the focus we had P to the H instead of the K. The directrix is now vertical. And you can see in the horizontal equation, the XH and the YK have been switched. Let's find the vertex, focus, and directrix of this parabola. This parabola is not written, the equation is not written in standard form because the standard form starts with a squared equals everything else. So let's multiply by 2 to get rid of the half and get the x squared by itself. Now since it's x squared, we know that is vertical. If we compare it to the standard form, we can see h is 0 and that k is 0. We can also see here that the 4p equals 2. So p must be 2 over 4, or a half. So the vertex is HK, which in this case is 0, 0. The focus is HP plus K, which in this case will be 0, a half plus 0, or a 0 half. And the directrix is y equals K minus P, or in this case y equals 0 minus a half, which would be y equals negative 1/2. All right, let's find the standard form of the equation of a parabola with the vertex at 0, 0. So I graph the vertex at 0, 0. And a focus at -2, 0. So I graph that. And I know the parabola bends around the focus, goes through the vertex and bends around the focus. And I also know from this that it opens towards the left. Therefore, I know it is horizontal. I know the P is from the vertex to the focus, and it's going to the left, so it's -2. My vertex is HK. So I have my H, my K, and my P. So since it's horizontal, it is y minus k squared equals 4p x minus h. Or y minus 0 squared equals 4 times -2 x minus 0 if I fill in the h, the k, and the p. Simplify, you get y squared equals -8 x. Let's find the vertex focus directrix of a parabola given by, we have both x squareds and x's. So it's not going to be easy just to write it as x minus h squared. What we actually have to do is we have to complete the square. So let's go ahead and start getting it into standard form. Let's move the y's to the other side in the 31. And then we'll complete the square. Remember, you'll complete the square by adding 1/2 of the b term squared. And let's do that to the other side also. Well, 1/2 of -2 is -1 squared is 1. So I have 31 plus 1 is 32. Then we can factor. This will become x minus 1 squared. This becomes 16y plus 2. So if we compare this to x minus h squared equals 4p y minus k, we can see, since it's x squared, we already knew this, that it was vertical. And h is 1 and k is -2. Therefore, the vertex, which was hk, is 1, -2. We can also compare the 16 and the 4p to get p is 4. Therefore, the focus, which was h p plus k, will be 1, 4 plus a -2, or 1, 2. And the directrix was y equals k minus p. Well, k was -2, p was 4, so it's y equals -6. Let's graph that last parabola. We knew the vertex was 1, -2. And so what we're going to do to graph the rest of it is we're going to solve it for y. So we'll divide by 16 and subtract 2. Now that we've solved it for y, we can make a table of values in the calculator. So you go ahead and make a table in the calculator and plot the points. there you have it. Write the standard form of the equation of the parabola with a focus 1, 2, so graph that. And the directrix, x equals 3, so graph that. You know the vertex is halfway between the focus and the directrix. So you know the vertex is there, and you know your graph bends around the focus away from the directrix. So from that, we can tell the vertex is 2, 2, which is our h and our k. We can also then count the p. From the vertex to the focus, we see p is -1. Negative because it's going to the left. So it's y minus k squared equals 4p x minus h. K is 2, p is -1, h is 2. And there we go.